Greetings, beautiful people. Welcome back to Find XYZ. If you are new to my channel, please subscribe. We are still on the road to WASI 2026. Let's try this problem. We have a coordinate of vertices of a parallelogram QRST of points Q 1,6, R 2,2, S 5,4, and T X, Y. We've been tasked to express the vertices as a vector, that is vector QR and vector TS. Hence, we've been asked to determine the values of X and Y. Additionally, we have also been told to calculate for the magnitude of vector RS, then to also express vector RS in the form of a magnitude bearing form where K is the magnitude and theta is the bearing. Then we've been asked to find the values of X and Y for this vector equation. Let's begin. The first thing that we are going to do is, because the problem is dealing with a parallelogram, we have to sketch our parallelogram. So let's do that. Now, whenever you have a parallelogram problem, the labeling of the vertices is very important. You always move in any direction, but the labeling has to be done in a consecutive form. So for example, you can decide to move in this direction or in this direction, doesn't matter. However, if you start, don't pause. For example, if I'm starting at Q, the next vertices should be R, then from R I move to S, and from S I move to T. This is very crucial. Then what is point Q? Point Q is given as 1,6, point R is given as 2,2, and point S is given as 5,4. Then finally point T is given as X, Y. Then what can we do? So we can connect Q to S. Let's do that. Now, what do you know about parallelogram? One of the key things about parallelogram is that they have opposite sides being equal and parallel. So we can say Q to R, indicating that I'm moving from Q to R, is the same as T to S. Then the arrow to show. Then Q to T, that is pointing to T. Take note of the arrows. Is the same as R to S, that is also pointing to S. Then Q to S can also be shown as vector Q to X. So let's write these important things. We have stated that vector QR is the same as vector TS, and then vector QT is also the same as vector RS. Please, the order is very important. You realize that I'm starting from Q to R, I'm moving in the same direction as T to S. You have to move in the same direction before you can say they are equal. Then if I'm moving from Q to T, it should be the same as moving from R to S. The direction should be the same for this to work. Then once this is set up, we can then go ahead to express vector QR and vector TS. So let's start with vector QR. Now, since we are given points, we can only express vector QR as a position vector. What does this mean? Now, given this coordinate system, I can decide to locate 2 points on this plane. So let's say point Q here and point R here. So this is Q and this is R. These are 2 points. Now I can decide to relate these 2 points to the origin. So this is the origin, that is O. So I can draw a line from Q to O, and I can draw another line from R to O. So what is the vector? The vector is Q to R. So let me connect these 2 points. That is Q to R. Now, if I want to move from Q to R, but there's a flag on this road, so I can't move from Q to R, is there any other place that I can pass to R? Yes, so I can say Q to R. I can move from Q to O. Then from O, I'll move to R. So from O to R. So see something. Where should I start from Q? I started at Q. Where am I going? R. I am at R. Objective has been achieved. Okay, so with vectors, start where you are supposed to start and end where you are supposed to end. That is all. You realize that moving from Q to O, if I want to move from Q to O, this is the arrow. I'm moving to O. So I can write Q to O as the same as O to Q. However, you realize that they are not the same. This is starting with Q, this is starting with O. What can I do to make sure that these 2 vectors are the same? By bringing the negative to indicate that I have changed the direction. So if I change the direction from Q to O, I have to bring the negative to show that I have changed the direction. Then we can say these 2 vectors are equal. So in place of vector QO, I can write it as negative OQ plus OR is the same as vector QR. Then let me arrange it and bring the positive vector first. So I can write it as vector OR minus vector OQ. So it means that I can express vector QR as vector OR minus vector OQ. There's a very easy way that you can do this. Always start from the back, and once you are starting from the back, if I'm moving from the back, it is negative. You can write vector OQ as small r minus then vector OQ as small q. Is that okay? So for example, if you are given vector AB and you are given 2 points, take note, you are given what? 2 points. You can express it as a position vector by starting from the back and say O to B. Then because you are starting from the back, you bring minus and say O to A, which is the same as small b minus small a. This is what we call position vectors. For this to work, you have to be given 2 points, and this we have points, so we can apply position vectors. Then let's substitute these vectors. They are no longer points, they are now position vectors. Now point R is now vector OR. And what is vector OR? That is 2 2 minus what is vector OQ? Vector OQ is 1 6. Whenever you are subtracting vectors, you subtract corresponding components. So the S component minus the S component, and then the Y component minus the Y component. So we can say 2 minus 1 and then 2 minus 6. Then what is 2 minus 1? That will give us 1. 2 minus 6, that will give us minus 4. Because when you are owing 6 cedis and you pay 2 cedis, you are still owing 4 cedis. So now we have established that vector QR is 1 negative 4. Now we are saying that QR is the same as TS. It means that vector TS should also give us 1 negative 4. But let's express vector TS as a position vector. So we are going to do the similar thing here. So we can say vector TS. If we want to express this as a position vector, we can start from O to S minus O to T. We are going backwards, so we bring the negative. And what is vector OS? That is point X. Previously, that is 5 4. Then what is vector OT? That is X Y. So we operate on corresponding components. So we can do 5 minus X and then 4 minus Y. However, we know that these two vectors are equal. Vector QR is the same as vector TS. So let's write here vector TS is also equal to 1 negative 4. Then we can substitute it here and say that okay, then 1 negative 4, which is the same as vector TS, is equal to 5 minus X for the S component and 4 minus Y for the Y component. Then we have two vectors that are equal, so we equate corresponding components. So we can say 1 is equal to, which is for the S component, is equal to the S component on the right hand side, which is 5 minus X. What can I do? I can say that I'm moving 5 to this side, so I have 1 minus, this is positive, so 1 minus 5 is equal to negative X. Then what is 1 minus 5? That will give us negative 4 is equal to negative X. Then we divide through by negative 1, so we have X to be equal to positive 4. So the S component of the vector is positive 4. Then we can do the same thing to the Y component of the vector. So the Y component on the left hand side is negative 4 is equal to the Y component on the right hand side, which is 4 minus Y. Similarly, we can move 4 to this side, so we have negative 4. This is also positive, so when it comes here to become negative, is equal to negative Y. So negative 4, you are owing 2 different people 4 cedis. You are owing 2 of them 8 Ghana cedis. Is equal to negative Y. So we can say Y is equal to positive 8, because I'm going to divide both sides by negative 1 and it will make Y to be what? Positive 8. Now let's see whether this is true. If I substitute positive 4 here, 5 minus 4 will give us 1. And if I substitute 8 here, 4 minus 8 will give us negative 4. So now we know point T as 4, 8, where 4 is the X and Y is the 8. So we are asked to express vector QR. So vector QR is 1 negative 4 and vector TS is also 1 negative 4. Then we are asked to also find the values of X and Y. We know X is 4 and Y is 8. That is the first part. So the first objective has been achieved. Then what is the second thing? The second thing is for us to find the magnitude of RS. So we are going to work on vector R to S, the magnitude. But before we can find vector RS, we have to know that vector. So let's find vector RS first, and when we are done, you find its magnitude. So vector RS is equal to, so we can express this as a position vector since we are given 2 points. So we can express this as OS minus, we are going backwards, OR. And what is vector OS? Vector OS is given as 5 4 minus vector OR is given as 2 2. So additionally, we operate on corresponding components. So we'll do 5 minus 2 and then 4 minus 2. Now what is 5 minus 2? That will give us 3. And what is 4 minus 2? That will give us 2. So vector RS is equal to 3 2. Then we have to find the magnitude of the vector. Now look at this. Since this is a component form of the vector, this is the S component and this is the Y component. So if I'm moving from, let's say this is point R and this is point X, so this is R and this is S, I can R to S. So watch this. Vector RS has a horizontal component and a vertical component. The horizontal component is X and the vertical component is Y. This component is 3 and this component is 2. You realize that this has created a right angle triangle, so we can apply Pythagoras theorem. So we can say that if I have a squared plus b squared, it will give me c squared. So I'm going to apply the same thing. Whenever I have to find the magnitude of a vector, it's just like saying finding the hypotenuse of a right angle triangle. So the magnitude of Rx will give us x squared plus y squared. Okay, so we are going to do the same thing here. So we can say the magnitude of Rs is equal to the square root of x squared plus y squared. And what is x? That is 3, so 3 squared. And what is y? That is 2, so 2 squared. Let's simplify this. The magnitude of Rx is equal to 3 squared will give us 9. 2 squared will give us 4. What is 4 plus 9? That will give us 13. So the magnitude of RS is root 13 units. So we are done with calculating for the magnitude of vector RS. Then we are asked to express RS in the form of a magnitude bearing form. Now, since we have been able to calculate for the magnitude, we are only going to calculate for the bearing. Then when we are done, we put the two together to form the magnitude bearing form. Now, bearing is any angle which is measured from the north in a clockwise direction. Take note, it has to be measured from the north in a clockwise direction. Okay, how do we find the bearing form of an angle? Since this is a right angle triangle, let me draw the north. So this is the north. It means that we need to know this angle. For me to know this angle, I can find this angle, which is theta. Then because this full angle is giving us 90 degrees, I'll subtract theta from 90 to get the bearing angle. So the reason why this is working is that the two components are all positive, so it's in quadrant 1. So let me give you a brief summary. When the vector is in quadrant 1, you do 90 minus theta. However, when it comes here to be 90 plus theta, the reason why it to be 90 plus theta is that if I measure from the north in this direction, watch this, this angle is 90, so I'll add theta to it. That is the angle. So I'll move from 90 plus theta. That is the bearing angle. So you take note of that. Then if I draw a line here and this is theta, watch closely. Moving from this point to this point is what? 180. Then I move from here, that is 270. And the bearing angle will move from this point till it touches the vector. But the whole angle is 270. So if I want the bearing angle, I will do 270 minus theta to get the bearing angle. So this is also 270 minus theta. Similarly, if I draw and this is theta, this angle is 270 and the bearing will move from the north till it touches the vector. That will be 270 plus theta. So if I want the bearing angle in quadrant 2, it will be 270 plus theta. Write this somewhere. But how do we find theta? Since you can find theta by using tan of an angle, whenever you are given the vector, look at the component. Is it positive or negative? Identify where it's going to be. So if all the components are positive, to be in quadrant 1, so this is positive, and this is negative, and this is also negative. So if the x component of the vector is positive and the y component of the vector is positive, the vector will be in quadrant 1 or positive. If the x component of the vector is negative and the y component is positive, it will be in quadrant 2. If all the components are negative, it will be in quadrant 3. And if x is positive and y is negative, it will be in quadrant 4. So take note of that. But here we are very fortunate, it is in quadrant 1. So we are going to use theta is equal to tan inverse of y over x to find theta. Then please, theta is not the bearing angle. Theta is the angle between the positive x-axis and the vector. That is not what you are looking for. The bearing angle is the angle from the north in a clockwise direction. So please never use theta. That is a trap. Look at the quadrants where the vector is lying and choose which of the operations that we are going to do, whether 90 minus theta or 90 plus theta or 270 plus theta or 270 minus theta. In this instance, we are going to use 90 minus theta because both components are positive. So let's do that. So what is x? X is 3, y is 2. So we can say theta is equal to tan inverse of what is y? Y is 2 divided by 3. And what would that give us? That is giving us 33.69 degrees. This is theta, but that is not the angle we are looking for. We are looking for the bearing. Because the vector is in quadrant 1, we'll do 90 minus theta. And what is theta? Theta is 33.69. So we'll do 90 minus 33.69. And what will be the bearing? That will give us 56.31 degrees. So the bearing is 56.31 degrees. So we'll just write vector RS is equal to, what is the magnitude of the vector? Root 13 units, comma, bearing is always written in 3 decades. So because 56 is 2 decades, we'll bring 0 in front because bearing, we write it in 3 decades. So I write 056.31 degrees, and this is the magnitude bearing form of the vector. Now you know how to calculate for the direction, which is tan inverse of y over x, but that is not what you are going to use. You have to look at where the vector is and apply which of them that you are going to use. So this represents the magnitude bearing form of a vector, but this represents the component form of the vector. All right, so let's do the last part of this problem. In the last part of the problem, we have an equation involving vectors. So let's solve for the values of x and y. So we have vector giving us s plus 3 and 2 minus y, x plus y is equal to 2 minus 1. Now, whenever you want to operate on vectors, you operate on corresponding components. So let's combine the two vectors, x plus 3 minus y, and we can do 2 minus into bracket x plus y. This is equal to 2, -1. Please take note, one of the mistakes that students make is that they will only assign the negative to the x, forgetting that the negative is affecting these two numbers. So if both numbers are positive, it means that now both numbers will be negative. So this can be simplified as x plus 3 minus y. Then we have 2 minus x minus y. When you distribute the negative inside, this is equal to 2, -1. Now when we have equal vectors, we can equate corresponding components. So we can say that x plus 3 minus y is equal to 2. Why? Because the s component here is the same as the s component on this side. Similarly, we can also say that 2 minus x minus y is equal to -1. It means that we have two equations. Let's simplify. Let's send 3 on this side and let's also send 2 on this side. So now we are going to have x minus y is equal to 2 minus 3. That will leave us with -1. Then we'll have negative x negative y is also equal to, then this is positive 2. It crosses the equal sign, becomes -2. Then -2 -1, that will give us -3. So we have two equations. This is our equation 1. This is our equation 2. What can we do? You can use any of the methods. You can use elimination. You can use substitution method. I want to eliminate. Now to eliminate, we are very fortunate the coefficients of both variables are the same. If the signs are different, add. If the signs are different means that one is positive and one is negative. When it happens like that, add. So watch this. If we add equation 1 plus equation 2, the sign for x is positive, the sign for x is negative. So when we add these two equations, x plus negative x will go to 0. Then negative y plus negative y will give us -2y is equal to -1, -3 will give us -4. Then we can divide both terms by -2, so we have y to be equal to +2. Then once we have y, we can substitute in any of the equations. So let's pick equation 1 and say that x minus y is equal to -1. But we know y. What is y? Y is 2. So x minus 2 is equal to -1. Then we'll send -2 on this side, so we become positive. So we have x is equal to -1 plus 2. So -1 plus 2 will give us x is equal to +1. Now let's see whether that is true. We are saying that x is 1 and y is 2. So x is 1. Let's put 1 here. Y is 2. Let's put 2 here. Let's put 2 here. 1 plus 3 will give us 4. 4 minus 2 will give us 2. So this is correct. Then what is x? X is 1. 1 plus 2 will give us 3. 2 minus 3 will give us -1. That is also correct. This brings us to the end of this question. If you found this helpful, kindly leave a comment, share this video to all your friends, and I'll be back with another video. I'm out.